Hey everyone, welcome to this first episode of this channel, Quantum Computing Podcast. And as you know, we are going to go through this book, Quantum Computing for Computer Scientists by Yanofsky and Mannucci. And we're going to dive right into this book. And we will start with the first chapter. Let me zoom in. Yep. All right, so first few pages, this is actually page number 7. But first few pages are some introduction content, how this book is organized, how someone can consume this book, what are some of the topics covered at a high level, and some other introduction content. This is a cool diagram that shows if like different ways of how to reading this book, where is there's a type 1 acknowledgement and yeah, so but we're gonna go sequentially, at least for now. We will start with the first chapter, which is complex numbers. So complex numbers sounds very well. It may sound very basic, or it may not sound that basic, depending on your background. But if you took some algebra in school, or maybe you're self-taught in some basic or intermediate mathematics, then you know what those complex numbers are. The reason all the books, including this book, but also including this quantum computing and applied approach by Springer, or this QCQI book, quantum computation and quantum information book by Mike and Ike. All of those books have some reference to complex numbers. Actually, quantum computing and applied approach has just like this has like a chapter dedicated to complex numbers and some operations. And the reason is quantum mechanics involves complex numbers. So quantum computing builds on top of quantum mechanics. So it's important to understand complex numbers. And actually, authors say it here that if you're familiar with complex numbers, then you can skip it, or they recommend you skim through this content and come back as for a reference in future if you need. So first page is just that, and seventh page, and the next page actually goes into some definitions. So what is a complex number? So complex number is made up of real number and imaginary number. So complex is real part and imaginary part, just are our lives, not my joke. And so what is an imaginary number? Okay, so let's go through it. So imaginary number is actually an imaginary number. So here we have to come up with not a real number, an imaginary number, in some situations where we cannot arrive at a certain solution with basic mathematics. So what do I mean by that? So for an example, let's just assume that there is this is an equation, that there is an equation which is x squared plus 1 equals 0, which means x squared is equal to minus 1. So what is a possible value of x? Now, if you think about it, if x is let's say a negative number, then square of that number, which is the multiplication of that number with itself, is gonna be positive, because negative multiplied by negative, so negative sign is negated out, so you get positive number. And same with a positive number, square of a positive number is going to be positive number. So it's not going to be possible to have minus 1 as the square of some number x. So it's not possible. But if such an equation existed, then we just have to if we just assume that, okay, it's not possible with our known understanding of world, nature, algebra, mathematics, that it's not possible to arrive at the value of x. But let's just assume that such a way of finding a solution exists, And if it exists, then maybe x is an imaginary number that is imaginary right now. Maybe in future we will know and we'll find more about this x. So yeah, so that's what imaginary numbers are. And having imaginary numbers make our lives easier, because in future, in some of the situation, in some equations, it might just be easier to have some terminology and some accepted way of representing things, so that we don't have to go through this every time we use the imaginary number. All right. So what is exercise? First exercise. So yeah. So this exercise says that verify that this equation has no solution among the real numbers, known numbers. And let's go through this exercise. All right. So yeah, it says what is the best way? Yeah, this is okay, I guess. All right. So x raised to the power 4 to x squared plus 1 equals 0, right? Which means that x squared plus 1 into x squared plus 1 equals 0. Now how did I do that? Well, I just did it in my head. You can verify x squared into x squared is this first term, and then x squared into 1, which is x squared, plus 1 into x squared, which is 2x squared, plus 1 into 1, 1. So this is right, which means x squared plus 1 equals 0, or x squared plus 1 equals 0. One of these two terms has to be 0. Now it just happens that both the terms are same, which means x squared plus 1 equals 0, which means x squared is equal to minus 1, which means x is equal to root of minus 1. So yeah, there is no such number. When you square it, you get minus 1. So there is no solution among the real numbers. And what is a real number? So real numbers right here is actually the set of known numbers. Okay, so like pi is a real number that it's 3.14 and it goes forever, but at least it's a real number. You can actually arrive at that number, use that number to derive different things. And there are other sets that you might remember from your earlier study, that there is a set of positive numbers, natural numbers, which is 0, and positive numbers and whatnot. So yeah, the next paragraph actually summarizes the same thing. And I, which is the root of minus 1, which is what we arrived here, and also here, is actually a very famous, well-known, fundamental, widely used imaginary number. If we use I, that just means it's a square root of minus 1. And see, this is the reason why it's so easy to come up with a terminology, so that we can use the letter I instead of square root of minus 1 every time we have to use the imaginary number. And if you combine imaginary number with real number, then you get a complex number. And the next example, yeah, it says find the value of I cube. Now, what is I cube? I cube is I square multiplied by I. So I cube is equal to I square into I. And we know that I is root of minus 1. I square is actually minus 1. So it's minus 1 into I, which is minus I. So I cube is minus I. And you can actually verify this. It's a nice book. It has solutions at the back. And what is the value of I to the power 15? It's the same thing you find, and there's a hint actually given. You can actually find lower powers of I, and substitute them here. So here it could be, let's say, I cube into I cube into I cube cube into I cube, right? Why I chose I cube? Because we already calculated I cube, that's why. So I cube I know is minus I into minus I into minus I into minus I into minus I. It should be minus I. Right, so let's pick a pair. Minus I into minus I is going to be I square into this pair, which is I square into minus I. I square is minus 1 into minus 1 into minus I, which is going to be minus I, same as I cube. All right, so we're going to end here, and then we'll go through more content in this format, short videos, about 10 minutes, and see you in the next video.